So the next topic which we will discuss is about the scoring. Scoring is basically how scoring basically says how relevant is our document to the search criteria which is being retrieved. So to illustrate this, what I will do is I will create a query and say match this term both uh, in job title or in job description. So I will pass a term and ask Lucene, give me the documents uh, wherein this term is present either in job title or in job description. So the more scored documents will have the term present in both of the fields. So I will do a new query. I'll name it as basic score query. I had to search in job title or job description. So what I will do is I will create a boolean class query1. This is should represents or and must represents and. This is query2, and then I will create a boolean query. We need a builder dot add clause, which is c1 dot add clause c2, and then build. We build the query and we just uh, return boolean query, right? So yes, give me the term Java, which can be either present in job title or description. Now we execute the query, but where are the scores? So for that we will have to modify our execute code, and it is actually present in this score document. So I will just introduce another sys out saying give me score. This is present in score doc dot score. It is a float value. Okay. Okay, let's try to run this program. Okay, so the topmost result will have the highest score. Just notice 0 0.6, 0 0.63, 0.59 and decreasing. The topmost job has the term Java both in job title as well as in job description. So likewise, if you go down, just have a look at this or this. It might be present in either one of these. I mean, either in title the Java is present or in description the Java is present. That's why we are getting the least score. If we don't specify any sorting criteria, the highest score will be on the top. Okay. The next thing which we will discuss is about boosting. So as I told you, boosting is basically to manipulate your scores. Basically, you want to give preference to specific terms, or you want to give lower preference to some terms so that the score of the document gets manipulated by Lucene. So to illustrate this, I will create another query saying like basic boost query. So in this, what I will do is I will pass two terms, one Java, another one is let's say Python. Okay, I'll create a query, then I'll use the term query. Let's try to search in description, and I'm saying it. So I'm saying, give me the jobs having Java or Python in either. Uh, so so what I'm saying is I'm creating a query stating, give me the jobs wherein the description contains either Java or Python. So any one of these gets the higher precedence. So now what I will do is I will just say, so both returns the same score. So no one gets the higher score. So anything which contains any job description that contains Java or Python gets returned. So over here, so the description contains Java. This also contains Java. This. So the Python is contained over here only to this job. So now what I will do is I will actually the next thing which we will discuss is about boosting. So the boosting is nothing but manipulating our scores, or boosting can be termed as you give some preference to specific terms, or you give some lower preference to specific terms. To illustrate that, what I will do is I'll create a query to match the terms either in I'll to illustrate that to illustrate boosting, what I will do is I'll create a query to match the term in description. Yeah, so I'll do like basic uh, boost query. I'll say we need, let's say we are searching for Java and uh, Python, and we are searching in description. So what this query means is we are searching Java or Python in description and give back the results. So you might be wondering, where are we boosting? So first let's take a look at this, and we will boost one of these terms to manipulate our score. Okay, it is Python. Okay, yeah, let's get started. Okay, just have a note that the first result, it says Python. The job title is containing Python, as well as in description it contained Python, then followed by our Java. So what we will do is we will manipulate the term Python search. So basically we will lower the preference of the Python. So how we can do that is we have to wrap this query to in a boost query. So we will say boost query. So whatever the query to, and how the boosting should. So anything which is more than 1 gets the higher preference. So anything lower than 1 gets the lower preference. So I'll say minus. So we will have to manipulate the results. We will have to wrap this query to in a boost query. So anything which is more than 1, anything which is more than 1 is considered to be giving higher preference. So negative considers as the lower preference. So what I will do is I will wrap this query to in a boost query. Boost query, say whatever the query which we will have to do. So I'll say minus 0.2 float. So the same boolean query, I'll put it in over here. Just have a note, the query was like this. Description should contain Java or description should contain Python. So now we are lowered the preference of Python by using this boost. So the first result was of Python. So let's run it again. So you can see the Python job had come in at the below with the lowest score. Why? Because we have lowered its boosting. So the query will look something like this. Description, search Java, description, search Python with a caret symbol and minus 0.2. That means we are lowering the preference of Python. Okay. Next we will discuss is about the highlighting. So if we had a use case wherein we need to highlight results, whatever we had searching in, then we use a highlighter functionality. We can use a built-in highlighter or we can use a customized highlighter to highlight the terms. Okay. To start with, what I will do is uh, I'll say I'll create a basic query for highlighting, or I can use the basic term query itself for highlighting. It gets the term searched in Java title. How it works is, uh, so before using highlighting, we will have to include the binary, or we will have to use the Lucene specific another binary for highlighting functionality. So the binary is we will have to include Lucene highlighter. Make sure we use 6.0.0 for all of the Lucene binaries. Okay, once we add it, our highlighter binaries are plugged to our project. You can see all over here, the highlighter is getting over here. Okay, so to illustrate this, I'm using the basic term, and then instead of execute query, I will create another query because we will have to modify more things in while executing it. Okay, so I'll just create this and I will use the same other logic for executing it. Then throw the exceptions, and then I will use a simple highlighter. So I'll use simple okay, HTML formatter. Sorry, I will use simple HTML formatter. So I will use simple HTML formatter. So we can customize with our pre and post tag. So I will use IntelliPath, and then again close of IntelliPath. So anything we encounter as part of our search term, we will embed that with IntelliPath closing, opening and closing tags. Now I will create a highlighter, then we create the highlighter using two arguments, one our custom highlighter and then with our scoring. So we can use a query scorer with whatever the query which we will have to execute. Okay, and then we will use a simple analyzer and highlighting KPIs. I just did a copy to clipboard. So I'll have to use index, and then we will create a analyzer. We will use a simple analyzer. I just did a code snippet copy. Okay, so what it does is uh, so we need a formatter. Hold on, we will just remove the errors. Yeah, so we will need a formatter, like how it has to be embedded inside embedded inside our search criteria. So any terms which is present in our result, it has to be pre and post tagged. Then highlighter is required, analyzer is required. So then we are using on top of title. So title has to be tokenized, and anything which having a score more than 0 has to be present in this tokenizer. So now what I will do is I'll just search with term Java and use the highlighting execute query. Yeah. So you can notice anywhere which is where the Java is present is being highlighted with IntelliPath. So this was our actual title, and this is our highlighting method or highlighting functionality. Next feature which we will discuss is about faceting or grouping. So basically, if we had to group the results, then we use faceting. To start with, we will have to include facet dependencies. So I'll use leucine facet. So this binary is required for faceting. Okay. So let us use the faceting for the field of a job posted by. So whoever has posted a job, let's figure it out how many jobs he has posted. Okay. To start with, so any field which is being indexed by sorted set doc values, those are eligible for facets. So what I will do is I will go to the place where we were indexing. Okay, so I'll read posted by, which was not read until now. Okay, so I will read this field and create a facet config. Okay, then I'll say config dot set index field. Then I'll say constant job posted by, and the index field name. It's basically creating a alias kind of stuff. Okay, then I will declare a new type of field called sorted set doc values facet field. Okay, posted by field. So it will have a dim value, which is nothing but our label, and the actual value present in this JSON. And document, in document we will add this field, and instead of returning document, we will have to go via this config dot build document. We will have to rebuild the document for our faceting. Okay, so what we have done is we have extracted the posted by, created a facet config, and then created a field, and that field is being added to document, and then whatever the facet config we have used, by that we have built the document again. Okay, so the next thing is we will use the basic term query itself, searching for Java in job title, and we will create another method for executing this facet. Okay, so yeah, we will need till this part. Okay, and then we will need this as a reader. This is basically a reader. Then I will use the same snippet. Okay, this is index searcher. So what it means is, so we are searching for the term Java in job title and passing it to this method. So we using sorted set doc value state. So using sorted set doc values reader state, we will pass the reader object, and the field on which we will have to perform the facet, we pass the index searcher, the query, and number of documents or number of facet results it has to return, then facet collector where it will be collected, and using that we will iterate uh, and fetch the field and then display the results. So if we run this program, it should give us the counts of the people who have posted a job. So yes, so it is basically indexing 5 jobs and searching for the title having Java, and then grouping it based on the poster name. So basically Karthik has posted 2 jobs, Anand has posted 1 job, Raj has another job. So there are 5. Based on this query, it has filtered one. There is one job wherein the title doesn't contain Java. Okay. And the last topic of Lucene is our special search. Special search is basically performed when you want to calculate the uh, distance between two places, or give me uh, what do you give me all the places covering the bounding box range, or some sort of distance calculations. Then we go for special search. To illustrate that, we will have to include special specific binary, which is Lucene, SPATIAL, special. Okay. To illustrate this, what I will do is I will modify our indexing part wherein we were gathering the posted by. Now we will include job lat long, which is already present in our JSON. We will basically read the lat long, and then we will convert that double lat double dot parse string, which is lat long. It is basically comma separated. We will split it by comma. Okay. Then the same thing with long. Okay. So how do we store it? We will have another field by name geopoint field. Okay. So we will just say lat long field, We will name it as our constants. Okay, lat long, and yes, we are storing it, and same gets to our document as well. So now what we have done is we have extracted the lat long from our JSON, parsed it and gathered as individual double values and created a lat long field and added to our document for indexing. Okay, and then what we will do is we will query for a distance. So what I mean is, uh, so let's say we are calculating, give me the jobs which are nearby to me, let's say 100 kilometers. Okay, so what I will do is create a basic geo query. So let's say my first parameter is number of kilometers, second one is from the current lat long, give me the jobs which are present of 100 kilometers in bounding box. So let's say I am giving lat long of Bangalore. Okay, 977.1946. So I will create a basic geo query. This is nothing but our kilometers. This is our lat from where we will have to search, then the long. So our geo point, okay, so we will have to use geo point distance query for that. So what I will do is I will search on constants dot lat long. We will have to pass from where we will have to search lat and long distance in meters, but we have passed in kilometers. So we will just convert that to meters. Okay, kilometers. Okay, sorry, multiply by 1000, which gives us in meters. Yeah, we are ready with our query. So what we are saying is, from this lat long, give me all jobs which are covering 100 kilometers of range. I need not use the facet, I'll just use the basic query execution. So this arbitrary lat long is of Bangalore, so it will give me the Bangalore jobs only. Okay, yeah, just have a look at this. So Bangalore and Bangalore. The moment I increase this to, let's say, 3000 kilometers, so we will get to see more jobs. Yeah, we get to see Mumbai, we get to see Hyderabad, we get to see Chennai. Okay, so how this Chennai, Bangalore and Hyderabad is coming? So basically we in the leucine the job files which we have created actually has the lat long in it. So this lat long is gathered from Google. So search Bangalore, get the lat long, add it over here. Similarly, search Mumbai, lat long to it. And then as part of demonstration, I am using this query and figuring out based on our losing query. So how does the query look like? It's look like something like this: field lat long. From this point, give me all the jobs covering the distance of these many meters. Okay, yeah. So I hope you have understood the complete Apache Lucene, its use cases, when and all we will have to use the query, various query types, when to use the query parser, and how do we index files, what are the index files, then 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 all its So this covers complete Apache Lucene tutorial wherein we got to learn about a lot of things like the query parser from indexing, terms, facet, documents, stop words, how index writer is used, what is a reader, boolean clauses, various types of queries, highlighter, range queries. Yeah, I hope you have understood everything. If you have any queries, you can drop a email to us at support@intellipath.com or visit us at intellipath.com for further updates. Yeah, thank you.